All right. Welcome back to another exciting episode of Health Without the System. I am Dr. Tim Scott.
And I am Mia Scott. Guys, welcome back. I feel like I was just sitting here.
And in many ways, we were. Sorry for anyone listening last week. We recorded that at about 10:30 at night, and we were pretty out of it.
Yeah, but we're back. We're back and better than
Tired.
before. So
Yeah. Feel re-energized now.
yeah, all right. So,
We have a cool episode today.
yeah, we're going to talk about probably one of the coolest topics. And let me start by saying that I feel like we could talk about this once again for weeks on how important your gut is and how it interconnects and talks to your brain. So that's what we're going to dive into today.
Yeah, a little bit of a breakthrough, shorter episode today going over it. I mean, there's a lot of detail we could go into, but I think the surface layer is what's important. And sort of the way to frame this brain-gut axis discussion is thinking about certain things, whether it's in hindsight, if you think back on this, or, future meals. I want you to pay attention to your body. And the questions are, have you ever noticed things like anxiety after you eat a high sugar load, or brain fog after you eat a big pizza dinner? Does stress make you crave more food or reach for snacks? What about like irritable bowel syndrome and depression? Do you have any of those symptoms, or have you been told you have both? And even like weight gain associated with low motivation. Like thinking about those things, can you put those together? Have you noticed that in your life? And if so, those are all results of the brain-gut connection, amongst other things.
Yeah, and it's essentially how your body and brain and gut are hardwired to directly connect to each other. So we think of these as not necessarily weaknesses, but just how electrical signaling issues, so to speak, rather than like some type of disease state.
Yeah. So like you might get diagnosed with IBS and depression, for
Right.
example, but really what you're having is an expected physiologic response to the input or stimulus that you're putting in your body. It's not a disease. It's not a weakness. It's the reaction that you would expect. But a lot of people don't know that. And even a lot of clinicians don't know that. And I would get, I mean, I guess this is a stat I'm making up, but I would guess that at least 50% of doctors, if you
more than
said,
that, yeah.
have you ever heard of the brain gut axis? I think at least 50%, maybe more, would say no.
Yeah. Or of patients who have, like Tim said, these mental health issues, what does their gut look like, which tells a whole different story. So
Agreed.
statistics, as you know, nearly 1 in 3 Americans struggle with anxiety, and 92% of adults are metabolically unhealthy. These are not separate epidemics. They are overlapping physiology. So like we said, here's the idea. The brain and the gut are directly connected. They're not two separate systems, and they talk to each other all day long. They are unified communication networks, and it is called the gut-brain axis or the brain-gut axis. Doesn't matter.
And if you look at individual components of this brain gut axis, I sort of think of it, honestly, like some people talk about it being like a little super highway for communication. And while that is true, I almost think of it as like a little village with highways within it. So within the brain gut axis, you have your central nervous system, which we've talked about that can include like the autonomics, like the sympathetic and parasympathetic, which were just in our episode last week,
yep.
along with all your motor neurons and things like that. You have the enteric nervous system, which is your gut, the vagus nerve, which is one of the cranial nerves, and it is responsible for that parasympathetic tone, your microbiome, which is the gut bacteria, your immune system, and tons of hormone signaling and pathways.
Tons.
It really is a city. It's a city.
It for sure is. And you cannot treat mood without metabolism, and you cannot treat metabolism without assessing your gut.
The gut.
It operates and it functions so well together. And if the gut's not right, then a lot of things aren't right. And that's something that we've learned in functional medicine. As Tim and I have done our training, that's like one of the first things ever to assess. If you have so many health problems, what's the gut doing? Because chances are it's one of the culprits. Not saying it's the problem, but you have to look at that entire city and what could be going on in there. So
I agree. Skin issues are another common one. And when in the ER now, when people come in with a skin problem, my mind immediately goes to gut health, which was definitely not the case a few years ago.
Nope, not at all.
All right.
All right, so let's get into the hardware, how the axis actually works. Number one, as Tim said, the vagus nerve, which is the superhighway.
Yep. This would be like your main artery, where we live, your I-75 running north and south. It's the big guy, the vagus nerve. And 80 to 90% of vagus nerve fibers send signals from the gut to the brain, afferent signaling, right? Not the other way around. And I think that's important to remember as we talk about this and talk about how important the gut is. Let that sink in one more time. 80 to 90% of vagus nerve fibers send signals from the gut to the brain,
Yep.
not the other way around.
They, like I said, they are best friends and they communicate all day long. So that obviously matters.
Yeah, so some things your gut is saying to your brain with 80 to 90% of those fibers every day would be like, if you want to go into stretch receptors, microbial metabolites, and inflammation.
Sure. So let's get into the little bit of the physiology of this. So stress or stretch receptors. This is essentially your fullness signaling. So when your stomach physically stretches from food volume, you have the mechanoreceptors in the stomach that will activate. So basically they send signals via the vagus nerve up to the brain to let your body know, hey, we're full. We triggered that threshold. We're full. And this is in the hypothalamus, which, like we said, is in the brain. And that's how the brain knows when your body is full, not from calories, but from this stretch receptor and signaling from the brain to the gut. This is also from these stretch receptors or peptides that are signals like the CCK and the GLP-1s. Hello, that's one of our favorite peptides. But once again, that feeling fuller signaling from the brain to, or from the gut up to the brain.
Yeah, and we talked about that before. This is, again, how everything's connected. So cholecystokinin and CCK that you just mentioned, that's one of the bigger enzymes that you'll lose when you have your gallbladder taken out. So again, not only are you losing storage of bile salts, you're losing one of your satiety.
I hate satiety.
Satiety signalers, CCK, and then you're losing some of your digestive enzymes. So, people think, oh, I got my gallbladder out, no big deal. And yet nobody talks to them about these kinds of things that can happen. Like I've said before, I think everybody who has their gallbladder out should reflexively be put on digestive enzymes, just like every woman started on birth control should be put on a B complex vitamin. But
sure,
we don't do that.
Yeah, clinical pearl right there. If you have your gallbladder out or you're having gallbladder issues, you can still save it. Don't jump right into surgery. You can kind of get rid of this or help this naturally, but if it's already too late and your gallbladder is out, I think it should be absolutely a must that you should try your best to replace the functioning of that organ, not just rip it out and say, oh, let's toss it in the garbage. That wasn't put there for, anything serious. No, you should be doing digestive enzymes, at least at your biggest meals, help your body break down some of these things.
Yeah, and we don't get paid anything. We don't have a partnership, but we like the brand Codage, Codeage, for a lot of different things, and they have a good fermented digestive enzyme.
It is fermented. So if you're a little bit more sensitive, then you'd have to do like a non-fermented one.
A different brand.
Yes, there's lots of really good brands out there.
Okay, so we're talking about physiology in this little village with our brain gut axis. You just talked about stretch receptors. The next is microbial metabolites.
Yep, and your vagal activation. For those of you who listened to our last week podcast, we talked about vagus nerve and stimulation. So your gut bacteria ferment fiber into these short chain fatty acids like butyrate. Very, very important. And these metabolites signal the endocrine cells, very scientific words here, which release hormones that activate this vagus sense. So essentially that signal, once again, travels from the brain or to the brain and can influence some of the mood changes or mood inflammation levels, stress levels. Very, very important. That's why that, connection with mood can be altered based on gut microbiome. So healthy gut microbes literally calm the system. So therefore, in opposite, unhealthy gut microbiomes can lead to anxiety, depression, mood changes, and altered mental state.
Yeah, and I think we'll talk about butyrate a little bit more again later, but that's probably one of the bigger short chain fatty acids we need to be aware of. It's like jet fuel for the gut. It's a big deal. Certain bacteria can also produce them as a byproduct. So we definitely want to keep an eye on that, store that one to your memory. Yeah. Another thing we talked about, or you quickly touched on, was inflammation and how inflammation, not only from within the gut, but outside of it, can actually reduce vagal tone. So you mentioned how these microbial metabolites can actually send signals to the brain and they can influence inflammation levels. Well, imagine if they're increasing inflammation and you also have a lot of systemic inflammation, maybe from diet and lifestyle or other disorders, that's all going to reduce this vagal tone. We mentioned how much that plays into sleep, and today we're talking about how much that plays into the gut. So when this gut lining is inflamed and you have these different cytokines floating around like IL-6 and TNF alpha, when these go up, these inflammatory cytokines go up, they impair that signaling and they shift your body towards sympathetic dominance. Again, that's that chaos.
Fight or flight.
Yeah, fight or flight response. And reduced vagal tone is associated with things like anxiety, IBS, depression, poor stress recovery, a lot of those things that we've been talking about.
Yeah,
So
you want good vagal tone because low vagal tone is associated with all of those things: poor sleep, depression, PTSD, IBS, obesity. And remember, heart rate variability is a proxy for this. You want
yes,
a good high heart rate variability
we
and
want
good vagal
flexibility,
tone.
autonomic flexibility. And remember, bad autonomic flexibility shows itself as low heart rate variability. And this is a bad thing. And it tells us we have low vagal tone.
And if you don't know what we're talking about, listen to our last
Yep.
episode.
KPIs for the body last week, key performance indicators, or the metrics that you need to be aware of in your own body.
All right, another shocking statistic headed your way. Patients with IBS are 2 to 3 times more likely to suffer from anxiety and depression. Coincidence? Nope. This is a shared access dysfunction. And way back then, you go because oddly enough, the gut is I wouldn't say like a nuance of being studied, but it is significantly newer, the stuff that we know about the gut now than we ever used to. And way back when, we used to think that anxiety issues, brain issues, mental health issues triggered IBS. So if you had this mental health issue, you would likely have some type of gut dysregulation. Now we know that there's a lot of evidence to say that that's actually quite literally the opposite. A disrupted gut or leaky gut or dysbiosis causes brain issues. So it's one of those things, what came first? Well, now we know that there's a lot of good data out there to show that some of these mental health issues, anxiety, depression, all these things are actually a gut related issue first and then stimulate mental health issues.
At least rooted in gut, or you can trace some portion of it back to the gut. And again, that goes along with the fact that we said 80 to 90% of the nerve fibers on the vagus nerve are afferent, going from the gut to the brain. And again, that just tells you right there, it's probably not going the other way around.
Yep. And anybody who has any type of mental health instability or needs some extra support, you will not go wrong addressing your gut microbiome. So you can always make things better by addressing what's happening in your gut. Yep. Anyway, number 2 is the enteric nervous system.
Yep. So we mentioned the vagus nerve as the superhighway. Now we have the enteric nervous system, which I kind of think of as like all the exits and branches, along in this one area of the highway, which is your gut. And it does have its own nervous system with about 500 million neurons, which is more than your spinal cord. Would anybody ever think that? You have more neurons in your gut than in your spinal cord. And we think of the spinal cord is like our backbone of life,
And your gut is very important with that. So and it's not just for digesting food, it's just constantly communicating with your brain. So the gut produces about 90% of your body's serotonin, but most of that serotonin will regulate your gut motility, your immune system, not just mood directly. So if you have ever been one of my patients and we've gotten on this discussion, you'll always hear me say your immune system lives in your gut. If you're chronically getting sick, if you're not feeling well, if you can't recover from, cold and flu quickly, you likely have some type of altered gut microbiome because majority of our immune system lives in there. Which then, in caveat to this, before I forget about that, if you are chronically on antibiotics, you're killing off all that good microbiome that's keeping your immune system alive and well. And now you have reoccurrent infections and over antibiotic uses because you can't get your immune system back on its feet because you keep destroying the microbiome that keeps you healthy.
I agree. And, we're talking about microbiome here, and it's just weird to think in that same discussion, speaking about serotonin, which we think of as more of like a brain neurotransmitters. Everybody's heard of these SSRIs, selective serotonin reuptake inhibitors, but 90%, you mentioned 90% of your body's serotonin is actually made in your gut. Quick recap. So serotonin is a vital neurotransmitter and hormone, and it regulates things like mood, sleep, digestion, blood clots, and
wound healing, which I thought was very interesting.
What else am I trying to think of here?
Yeah.
And wound healing. Yeah, I actually really didn't know a whole lot about the role in that, but I think that's kind of cool too. And I think it has a little bit to do with some of those, we've mentioned some of those genes before, like mTOR and AMPK, and I think it's serotonin's influence on that. But anyway, while serotonin is acting within the central nervous system to influence like happiness and anxiety, and that's why we think of it as a mood neurotransmitter, 90 to 95% of the serotonin, again, produced in the gut, is actually managing motility and secretion. So it's incredibly more important in the gut than it is in the brain, arguably, based on those statistics.
Yeah. So that's when it's going well. Now, what if the gut is becoming inflamed? Well, things can change rapidly. The amino acid tryptophan, you guys have heard of that. That is what's, makes us a little bit sleepy in our turkey at Thanksgiving.
Yeah.
That is the raw material for serotonin, hence, the natural serotonin, so to speak. And that gets diverted down inflammatory pathways instead of being towards the serotonin pathways or production.
Yeah. And
So,
then naturally, when you do that, you're going to
yeah,
shift your whole neurotransmitter balance, right?
yep,
So it's going to alter the vagal signaling, and then it's going to contribute to mood changes, anxiety, low motivation, all that because you have this mood hormone in your gut,
yeah.
and you're
If
not
your
going
gut is inflamed and mad, your brain will feel that. They are best friends. I cannot stress that enough.
agree.
So, number 3 now that we're going to talk about is the microbiome as an endocrine organ. The
Agreed.
microbiome, which is very new. Like I said,
Yeah.
it's I wouldn't say like new research, but newer. We're establishing that we are more our gut microbiome. We have more gut microbiome species or populations than we do our own
More
DNA.
more bacterial
Yes,
DNA
Yeah,
in
so
our body
more
than human
bugs
DNA.
than
Yeah.
So essentially, and when you think about this, we're more bacteria than we are our own DNA,
Yeah,
which is wild.
that's kind of crazy.
It's a lot.
So this is cool. This is number 3 that you mentioned. Microbiome is an endocrine organ. So endocrine organs are like hormone releasing organs that you think of, like your pituitary gland,
Yep.
your thyroid gland, your thymus, right? Your ovaries, your testicles.
Insulin, your estradiol, like all of these things those are hormones that produce it. So think of that as a stimulator like that.
Yeah, so an endocrine organ, the
Yeah.
organ that produces those. And I just think it's really interesting to think of the gut bacteria as an actual organ in your body. So like you mentioned, they don't just help with digestion, they function like a hormone producing organ, and they manufacture different signaling molecules that influence immunity, metabolism, and brain chemistry. What does that sound like? A hormone maybe?
Yeah.
So
Yep.
anyway, kind of cool. But this is where, we can talk about butyrate, that again, one of my favorites, and that's just sort of like your jet fuel for the gut.
Butyrate is a short chain fatty acid produced when gut bacteria is like fermented fiber. So it's the primary fuel source for colonocytes, the cells that are lining your large intestine. And when those cells are well fueled, they maintain the tight junction integrity, meaning that your barrier stays sealed. So let me give you a little bit of an imagination here. Imagine that your intestines are like a hose, okay? Like a hose that you water your garden with. And that hose is nice and tight. Those tight junctions, or basically all the fibers of that hose, are nice and tight. You don't have any leaks of the hose. Let's say that hose gets real hot on a day and gets inflamed and starts to stretch out, then you can have little breaks in these fiber, or AKA your tight junctions of your gut. They'll spread apart once they get inflamed, irritated, pissed off, whatever you want to say. And then you can have particles that will leak outside of your GI tract, AKA your hose, and that's no good. So you want that barrier to stay sealed. Yes, you'll have some minor permeability as things that need to cross are allowed to cross, but you do not want that permeability to be extreme, because then you can get an increased risk of all of these things, which we'll talk about: inflammation, cytokines, sensitivities to food. That's a huge one.
Yeah, through like molecular mimicry and other things like that.
Yep.
Another big one is the bacterial byproduct LPS, lipopolysaccharide. You'll probably hear that come up a lot. When that gets into the bloodstream, that can cause almost illness-like effects. Like you can feel fevers, chills,
Like flu-like
aches.
symptoms,
Yeah, flu-like symptoms. So that's why a lot of times when people are doing cleanses, you'll hear them talk about doing binders along with it so that it can technically absorb all those microbial metabolites that die off and get them out rather than back into the bloodstream.
Correct.
But yes, I agree. You were talking about permeability, intestinal permeability, definitely important. And you were also talking about butyrate and what it is, the short chain fatty acid produced when certain gut bacteria ferment fiber. And I did a series on this on my TikTok where I was talking about different like keystone bacteria, things that we found in ancestral humans that are kind of gone from us due to different modern things, such as maybe formula, broad spectrum antibiotics, glyphosate, other things like that. But one of them that I find really interesting is called Faecalibacterium prausnitzii. I believe I'm saying that right. Pretty close.
I mean, I feel like
Yeah.
nobody can say any of these right, so
Yeah.
we're just winging it out here.
But anyway, that one was an interesting one on my TikTok, and that's one of your better butyrate producers. And a lot of people, they just don't really have that as part of their microbiome anymore. A little bit harder to replace and get that to seed, but it's a good one if you can find a nice, good probiotic. And then another one, and I find this interesting, is within the Clostridium family. So we think of Clostridium in terms of C. diff, Clostridium difficile, which is bad for our gut, right? That's a pseudomembranous colitis, causes really bad diarrhea and can make you very, very ill. But you also have to remember there's good Clostridium species, and they are some of our butyrate producers. So when you take medications like antibiotics for repeated C. diff and you wipe out Clostridium, you are actually hurting yourself in some ways. Now, again, if you've been diagnosed with C. diff and you need it, you need it. It is what it is. But there's just consequences. Every action has a reaction. So.
Yeah. And it's not about like these good bugs. They have to be just in check. You can't have an over or under population of certain species because then they can outrule and dominate and kill off the rest of the good ones and things like that. So moral of this story is you want a very diverse gut microbiome, an equal amount of these good species that can keep each other balanced and break down your food and absorb the nutrients that we need. And a random fun fact for you, I don't even know if we touch on this in the podcast, but we ourselves cannot digest fiber. That is specifically for our gut microbiome to eat and break down. Our body doesn't use it like we think it does. It's our gut microbiome or our microbes that eat and consume the fiber to survive, which is why fiber is so important. They digest food, they keep us regular, all the things. And there's a really good book that really changed my perception on our gut health, and that's called Fiber Fueled by Dr. Will Bolsewicz. He's talked on many podcasts, but my goodness, does he open your eyes on how important your gut is. And like I said, if your gut ain't right, ain't nothing gonna be right in your body.
Yeah, I liked the book Super Gut by Dr. William Davis. That was my big book on that. So both two good authors, good books. One other interesting fact about butyrate before we move on is that it actually can cross the blood-brain barrier, and it's a histone deacetylase inhibitor, so it can influence gene expression, and it can actually reduce microglial activation. So one of the things that we've talked about is how acetylation can turn different genes on and off. You may suppress good genes, suppress bad genes, activate good genes, activate bad genes. So just another thing to keep in mind, bacteria, a short-chain amino fatty acid that's produced in your gut, butyrate, can actually get into your bloodstream, go up to your brain, and have effects up there too. So again, the brain-gut communication axis. So.
Yeah, and how much the microbes do. So certain gut bacteria actually can produce GABA as well, which is the brain's primary inhibitory neurotransmitter, your GABA receptors. Now, the GABA doesn't necessarily, all of it doesn't cross into the brain, but it influences that vagal signaling and can help modulate that stress response. Think about these GABA receptors. It's your calming receptors. Like, for example, my females that are going through peri and postmenopause that need their progesterone because they don't have any more. Progesterone can help stimulate those GABA receptors. It's your calming brain hormone, helps you relax, help your mood be stabilized, help you sleep more deeply and restoratively. So found it very interesting and cool that gut bacteria can also help produce some of this GABA.
Yep. So we've talked about butyrate, GABA, dopamine precursors. So your microbiome can influence levels of tyrosine and phenylalanine. And these are both precursors to dopamine. And it can also affect how those dopamine receptors are expressed, whether they're upregulated or downregulated. So dysbiosis, which is overgrowth of what's considered the bad bacteria in your gut, can blunt that reward signaling, and that can contribute to low motivation, more cravings, and actually compulsive eating behaviors. So I find that kind of interesting, how dopamine plays a role in the precursors from your microbiome.
Yeah, it goes back to the saying when people say you are what you eat. Well, technically, yes, but you are actually you are what your gut microbiome eats, which is, goes into, that's that reward pathway too. So remember, you can have those dopamine signaling even with bad food, and that's a constant trigger, which we'll get into.
And we mentioned they are also involved in the tryptophan metabolites. So just coming back to that again, and that, as we said, can lead to serotonin production or can lead away from serotonin production down the inflammatory pathway. And that can, of course, worsen fatigue, lead to mood issues, make you feel brain foggy. So really, the big picture here is just kind of thinking how dysbiosis or overgrowth of bad bacteria, not enough good bacteria, can lead to things like lower butyrate that can weaken your intestinal barrier. You can have more LPS or like lipopolysaccharide getting in the bloodstream. That's going to increase cytokines. It's going to activate your microglia. That can cause mood shifts. The big picture is gut bacteria play a role in multiple different hormones.
Yep. You don't want that membrane to be too leaky. It can cause a world of issues. All right. So your microbiome, like we said, not passive. It's a biochemical command center. And another statistic for you, the average American consumes less than half the fiber we need to feed a beneficial gut bacteria. We used to eat about 80 to 100 grams of fiber a day from roots, tubers, gardening, seasonal plants, unprocessed food. And today, right now, that statistic stands that the average American consumes about 15 grams of fiber, which is insane. And unfortunately, it's mostly refined. So not only is it significantly less fiber, it is probably the worst kind
it's like
of fiber.
It's the people buying Triscuits thinking you're getting your fiber,
Correct,
and
or Cheerios.
And that used to be me. So listen, no offense to you until I learned. I used to think Triscuits were a great source of fiber and I loved them. And You wouldn't catch me eating them.
Yeah, not so much. So that means our gut bacteria doesn't get the substrate that they need to make butyrate and to be healthy.
Or
and
other things like that we mentioned, GABA,
Sure.
tryptophan, metabolites, all that stuff. So.
Yep. So no fiber or low fiber equals no or low
Yeah.
butyrate, which means weakened gut, inflammation, brain fog, anxiety. You can see how all of this connects. So ultra processed food, it's not just empty calories. We're basically starving the main organ that can regulate our brain. And if that is not a huge take home point right there, I don't know what is.
Yeah. So now kind of switching gears a little bit, talking about like blood sugar and stress, and then these different metabolic signals that go to the brain. And of course, almost none of our podcasts would be complete without a discussion about glucose. And so we'll kind of talk about glucose stability here. I think it's important because you have to understand that glucose is the source of fuel, the primary source of fuel for the brain. And the brain uses about 20% of the body's glucose, which is kind of a lot when you think about,
Considering organ
it's
size
just this
compared to
little
your body.
brain up here with
Yeah.
the rest of your whole big body. But the interesting thing is it cannot store glucose. So
Yeah.
different things can happen when glucose drops, right?
Yep. The brain senses the fuel threat because, of course, like Tim said, it can't store fuel. So basically, it senses that when it's
like,
low.
uh-oh,
And, yeah.
low. It's like the light coming on in the
Yeah.
car, and it's like, we need to pull over. We need to get fuel
Right.
somehow.
We need to,
And-
engage all these things.
Right,
So what
and-
happens?
yeah.
Hypothalamus in your brain activates your sympathetic nervous system, releases adrenaline and cortisol, which, as we know, cortisol will then spike glucose.
Yep.
But these hormone signals, it basically signals to the liver to break down glycogen and then to start reproducing new glucose through the gluconeogenesis. And that's all very rapidly to restore fuel to the brain.
Yeah.
So this happens incredibly quickly if you become like a hypoglycemic state.
Right. And so the reason you need to understand that, or how to contextualize it, is how I mentioned earlier, like, do you notice an anxiety attack or anxiety feeling after a carb heavy meal? Like, let's say, for example, you eat a big bowl of Lucky Charms for breakfast, or maybe a big bagel with jelly on it, right? That's a big carb sugar load. Do you notice shortly after, that you start to feel that way? It's again, how the gut can relate to the way that you feel. And it could be, that feeling could actually be catecholamines from the sympathetic nervous system. So, it could be these different adrenaline, cortisol, things like that, stimulating this response.
Yeah. And like I said, I mean, trial and error what works best for your body. But like when you have in the morning, if you're having just cereal and high glucose meals, I always say what comes up must come down. And you can immediately, like after that meal comes and starts to break down, you can have this anxiety or pacing or anxious feeling or feeling starving and all these things that you just don't feel yourself because of that glucose response versus a nice stable meal. Remember, it is all about stabilizing your glucose and making sure that it's
don't
stable.
want big swings up or down. You just want it to be, you don't want it to stay high either. I mean, you want to
Correct,
be in
yeah.
a good number, but you want to prevent the big peaks and the big valleys.
Yep.
So continuous glucose, this is a good statistic. Continuous glucose monitoring shows that even quote unquote healthy individuals can experience glucose swings over 40 to 60 milligrams per deciliter after a common processed meal. And that's a big deal. That's a stress event to your body. And remember, this isn't in the person who's suffering from what's considered autonomic instability or poor glucose control, poor insulin sensitivity, right? This isn't considered healthy individuals. So that's how, much these meals can affect you.
And I honestly would beg to differ that it's worse than that unless I was just a statistical
probably
outlier, because when I used to wear, I wear a CGM a few times a year just because, once again, data. The more knowledge that you can have about your body, the more that you can do and to better your body. And so I was wearing a CGM, and I don't drink anymore, but I remember that we were at a restaurant. I was eating a piece of bread, and they delivered my margarita. And I wasn't even a fourth of the way through, and my phone is like freaking out, alarms going off, and I'm like, what is that? And I look, and my blood sugar was like 185 or 190, and I was like, holy crap, like just a fourth of a margarita and a piece of bread. And granted, that was a blast to my cells in my bloodstream, but those are things that where I'm like, it really puts into perception or perspective. Yeah. That how just crazily that this can hit you so fast, and then boom, you can feel that jitterness and anxious feeling and all the things. But
you can
anyway.
almost feel like that sudden, like I'm going to die kind of feeling,
Yeah.
imminent death. Yeah.
You just
It's
feel
crazy.
so anxious. But anyway.
All right. So insulin and dopamine, these two
yeah.
are inherently connected as well. And this is important when you're talking about glucose stability and blood sugar and stress. Insulin crosses the blood-brain barrier. So chronically elevated insulin levels will impair that dopamine receptor signaling, which is that reward system, and it will reduce that reward sensitivity. It will also increase compulsive eating patterns because of that. And insulin resistance, which comes from chronically elevated insulin, correlates with depression, cognitive decline, and increased Alzheimer's.
Yeah, the increased risk of Alzheimer's. That's now being called like the diabetes 3 or type 3 diabetes because of the glucose dysregulation also in the brain. But anyway, your anxiety might not be the physiological, it might be actually glycemic, which brings me to a point that we've actually had a few friends that have had this where if you have blood sugar issues, it can very, very clearly mimic an anxiety or panic attack or things like that. So when I'm having patients that are midlife and they're saying, like, I've never had this onset of panic attacks or anxiety or of shaky irritability, number one, obviously hormones. That's a thing to circle back to. But number one or number two would be glycemic control and seeing what they're doing. It also brings me back to the point where Tim and I were both emergency medicine background. And whenever you had somebody that was hypoglycemic, they become in such a panic state where, I mean, we've had nurses straight out be knocked out cold because when your blood sugar drops, you can feel like you're just out of your mind. And obviously that's the extreme cases where you need immediate intervention. But it just goes to show you how crazy of an impact that low and high glycemic can impact your brain.
Yeah, I think so. You can't have a discussion about the gut without discussing inflammation. And sort of when the gut is speaking and fire is coming out of its mouth, it's going to affect everything on your body. So we mentioned just a few minutes ago leaky gut, and we talked about LPS or lipopolysaccharide. So again, we mentioned if you break down that barrier in the gut, that's called leaky gut, and that's LPS or byproducts of bacterial metabolism can enter the bloodstream. We mentioned this can cause immune activation, and it can activate things like TNF alpha and IL-6, which are these inflammatory cytokines, and those can actually cross into the blood-brain barrier. So that fire-breathing dragon spitting the fire out now gets in your blood and goes into your brain. So what happens when these inflammatory cytokines go into your brain? Well, first and foremost, they interfere with dopamine synthesis, and they reduce that receptor sensitivity in these reward centers like the nucleus accumbens. And we've talked a little bit about how reducing that receptor sensitivity to dopamine, so essentially down regulating dopamine receptors, means less pleasure response, right? And that leads to a lower drive and increased susceptibility to things like cravings, snacking and binge eating. So you have to think about that kind of stuff.
Yeah, and the cytokines will also suppress production of the brain-derived neurotropic factors, or the BDNF that we mentioned earlier, which supports that neuron growth and that, synaptic plasticity. So basically another way to think of this is how your brain learns and adapts and forms new memories.
Categorizes emotions,
Sure.
responses, things like that. It's all important, and inflammatory cytokines can blunt that. I think that's really cool to think about.
Yep.
BDNF is a peptide that a lot of people do. I haven't personally tried that one, but
I'm
it's
sure
an
eventually
interesting
we
one when
will.
you think of neuroplasticity,
Yeah, for sure.
So-
So, like Tim said, the opposite obviously would be impairing learning, resilience, mood stability.
Yeah.
So that it's just so important. Once again, it goes back to inflamed gut can mean you can literally lose memory and focus and concentration with an inflamed gut. It's very, very powerful.
We mentioned microglia a couple times on this podcast, just to dive into that a little bit more. So microglia are basically your brain's immune cells. They're kind of like the waste cleanup within the brain. And with these inflammatory signals, when they cross the blood-brain barrier, they can activate these microglia. And that's not always the worst thing. I mean, there are some positive effects to microglia, but when they're overactivated, they can release more inflammatory mediators. They can amplify this neural stress within the brain, and they can disrupt some more of that neural transmission. So imagine you've got dopamine receptors downregulated. Your BDNF is low, so your neuroplasticity is down. Your microglia are activated with inflammatory mediators disrupting other neurotransmission. Again, you can see how these effects all start to add up. And then, of course, once, motivation's dropped, rewards dropped, then you're kind of shifting into more of like this energy conservation mode in the brain. You're seeking more goal-directed behaviors, and then that will show up as things like fatigue, apathy, low motivation. I can't get there, because your body
Right.
needs it. It needs
Mood
more.
and
Yeah.
mental health disorders, because elevated inflammation markers are found in up to 30 to 40% of patients with major depression. I mean, that is just
That's
massive.
crazy.
It's not a serotonin deficiency problem. It is an inflammation problem that will directly impact your brain.
And it leads back, or it starts in the gut.
Yep. Yep.
All right. So the other thing when talking about inflammation, we talked about leaky gut and LPS. Let's also just kind of talk about it, toxins real quick, because these amplify everything. This
Sure.
is kind of your area that you like to speak on.
For sure. Pesticides, plastics, molds, toxins, heavy metals, and these just don't impact the gut, obviously. They wreak havoc on the body. They can disrupt your mitochondria, your powerhouse of your cells, which are needed for energy production and to keep all other cells in check. You can have an increase in oxidative stress due to these. Oxidative stress, very, very inflammatory to your body, no good. They can also alter the microbiome diversity. So, as we know, especially these pesticides, they can wipe out our gut bacteria. And you almost wonder if there's a correlation with that with some of these glyphosates and cancers, because once again, immune system lives in your gut. So you want to make sure that you're trying to stay away from these as much as you can. And then it can also increase your blood-brain barrier permeability. So your brain has a protective mechanism with it. It's called the blood-brain barrier, where it will not let certain
It's
things
like a
in.
sieve or a screen,
Yes,
like a
exactly. It's
cheesecloth.
basically like a screen. It's an amazing, amazing little backup thing that we have in our body as a protective mechanism. And when we have these inflammation states, or we're having pesticides and heavy metals, we can have an increased risk of this permeability, meaning things that should not be in our brain are getting in our brain. Aluminum, microplastics, no good.
Mia, did you know that over their lifetime, the average person is exposed to over 80,000 synthetic chemicals that have been introduced to society since World War II?
And let me guess, were they ever tested?
For long-term neurotoxicity? No, they were probably tested like one
They
day,
were
like,
probably
oh,
tested under the
yeah,
Gross laws.
yeah, you didn't die. It's good.
Yep, this is relatively safe. We can continue. But anyway,
I think it's important to think about this kind of like little quote here too. If your brain is inflamed, you cannot out meditate it, right? Like you can't make inflammation go away by, I mean, yes, you can help those processes rooted in good lifestyle behaviors like morning sun, meditation,
if
exercise, and
inflammation
sleep.
was based off cortisol and adrenal issues because of stress, absolutely.
Right. And that's a help, and you have to start there. But again, you also have to identify the root. You know, every input has a reaction, and you have to look back at the inputs as well.
Yep. All right.
Let's talk
Next.
just for a minute about dopamine, cravings, and obesity, since again, these are things. Dopamine is kind of a theme in the last couple podcasts as well. It's very important in both the brain and the gut. And then, of course, cravings and obesity. Obviously, that's something we deal with a lot with metabolic and weight management patients. But you, as our listeners, probably deal with these things a lot too.
Yeah, and we know, so number one, let's talk about the hyper palatable foods. Obviously, this is very, very processed foods. You'll hear us talk about this in our food pyramid and the way that they built foods to be extremely addictive. And so when you add some sugars and some fats and some salt, it's basically an engineer for a reward system for your brain. So you have a massive dopamine surge once you're eating this, and then the receptors are downregulated, and then you become tolerant, and then, hey, I need more. It's like that theory that, oh, you can't just have one bag of chip. Well, they're salty, they're a little bit of sweet. They are very addictive.
Yeah, and people should know this by now, but there's tons of good studies out there showing different kinds of PET scans and MRIs and highly processed foods activating the same reward centers in the brain that addictive substances and very pleasurable things like sex, gambling,
cocaine.
like
I was just about to say that they were doing scans on, some of these things that have the same response as doing cocaine as some of the food intake would be, which is just, no pun intended, mind-blowing.
And willpower, your ability to resist these things fails at some point because neurochemistry adapts. So yes, you can say there's a lack of willpower and just don't eat it or don't do that drug or whatever, but there's a neurochemical component behind it. And for some people, it's very, very powerful.
Yeah.
So
and go back and listen to our food pyramid episode where we talk about how food is very scientifically made to make us very addictive to it and keep us coming back for more. They have spent thousands and thousands of scientists, or put thousands of scientists towards how to make food addictive. These were the same scientists that were digging into how to make cigarettes addictive. So don't think that hyper palatability foods are a mistake. They are not.
Yeah.
So there's that.
And then we kind of touched on this, so I'm going to kind of gloss over this section, but microbiome and cravings. We've talked about the fact before, when you crave ice cream, that's not necessarily you. That's usually bacteria in your gut hungry, and they feed off of different products within that ice cream or that chocolate or that processed cookie. So certain gut bacteria preferentially thrive on simple sugars. And so when they are well fed, they produce metabolites and signaling molecules that stimulate these enteroendocrine cells in the gut lining, and eventually you're going to want more sugar, right? They release appetite hormones like ghrelin and this peptide YY. And At the same time, microbial byproducts can activate afferent fibers of the vagus nerve, like we mentioned, and that sends real-time signals to the brainstem and hypothalamus. So this neurochemical reaction happening in your gut leads to an electrical signal that travels up the superhighway to your brain and says, I'm hungry, get me simple sugar in the form that you know that you're used to and that you like.
Yeah. Yep. And for my patients who need extreme diet U-Haul and they're basically changing everything about their diet, I will warn them that you will likely have some type of little bit of like a flu-like symptom period because what they're eating now is keeping that bad bacteria alive, hence why they're constantly craving these crappy foods. But then when they stop eating that bad bacteria starts to die off, and then they release an endotoxin because they're dying. And then you can feel that flu-like headache, fatigue. Sometimes you can get joint pain and things like that. But rest assured, it gets better. And then once you start replacing that with good gut bacteria, then you start craving things you never would think of, like fruit and vegetables.
Yeah. So we also mentioned dopamine, the reward center in the brain, and let's talk about protein, one of our favorite things, for a moment. So just like tryptophan is a precursor for serotonin, tyrosine is a precursor for dopamine. And when you're eating proteins and breaking them down into amino acids, you'll get tyrosine, which is that precursor for dopamine synthesis. When you eat adequate protein, you're supplying that raw material for dopamine production, but you're also stabilizing the post-meal glucose levels, and you're preventing insulin spikes and crashes, like we mentioned, that trigger those stress hormones and drive more reward-seeking behavior. So again, also, protein will stimulate some of those different hunger and fullness hormones that we talked about and they suppress ghrelin, your hunger hormone, and stimulate the fullness hormones like GLP-1 and peptide YY. So.
Yep, which is why all of our metabolic patients, they know to eat a lot of protein. A low protein morning essentially is going to mean unstable blood sugar, weakened of that feeling fuller or that satiety signaling, and then it can reduce that dopamine tone, which then will often show up as a crash. A few hours later, you're jittery, you're shaky, you feel like you almost need caffeine. It's really that you just needed a lot more protein at your breakfast, and not such a processed one.
It's really, this is where it's important to get the knowledge so that you have the power, right? You need a way to interpret the signals that your body gives you. And you'll often find the people who are healthier, who maybe look healthier, feel healthier, are more in tune with their bodies, and they'll tell you that. Like if they're shaky, if they're moody, if they're having a craving, they're usually going to they're not going to say that like, oh, I'm very moody today. They're usually going to like say that in a way, oh, I ate sugar for breakfast and I don't normally do that, or I skipped this or that, or I was up late last night. And again, it's just learning and paying attention to the way your body communicates to you.
Yeah. And then the less that you do some of these things, the more that your body recognizes when it's not right. So for example, I rarely ever get Starbucks anymore, but when I do, if I have a big Starbucks cup with like a caramel macchiato, I feel horrific. It is so much sugar. I feel shaky. I feel like I physically have to run around the house because I'm just going to explode. And that's that like crash, that massive blood sugar that's dumping. And then I feel like I'm just an anxiety.
I can't even, I was already like I used to get 3-4 years ago, I would get Starbucks 5 days a week. Then we switched to our own homemade coffee. And now I've actually started taking that to work at the various ERs I work at. So I almost always have a homemade coffee. But ever since I saw just not long ago, Paul Saladino share that TikTok where he like melted down a Starbucks cup and showed us that it wasn't actually even like paper or cardboard. It's actually plastic. I'm just done with Starbucks.
It's lined. Yeah. So then it's just leaching. And obviously they don't have an organic coffee. So it's just a steeped cup of glyphosate, and then it's steeping in plastic.
Yeah,
it's like the worst thing that you can do.
I can't do it anymore.
I know.
All right, let's talk about how you fix this, man. How do we repair the gut axis? Well, first and foremost,
sugar stabilizing. You have to stabilize your blood sugar or else everything else can go out the window. So 30 to 40 grams of protein per meal. Aim for a few big meals a day of that. Fiber before carbs. You want to coat that stomach lining so you have less of a glycemic spike with that. Walk after meals. I tell all of my patients to do this, especially, I mean, I don't want you walking all day long. I guess if you could, that'd be great.
Yeah.
But at least walk after the biggest meals of the day.
If you're going to do something, do that. Start there.
Yep.
Right.
And then stop with the added sugars. They are freaking everywhere. No high fructose corn syrup in your house. Quit pop. We don't have any of that. If anything comes in with high fructose corn syrup, it literally goes in the garbage.
Yeah.
And we used to donate all of this stuff that came into our house. And now I'm like, now I feel bad giving this away to somebody. So I just throw that crap away.
We
so
do. Yep. We're not giving away the crap.
And no foo-foo coffees.
Stable glucose leads to stable catecholamines, which are those fight or flight hormones we've talked about, in a more calm, vagal associated nervous system. Step 2.
Heal that gut. Whole foods.
Heal thy gut.
Whole foods. Back to the basics. Less processed. The less man touched it, the better. Fermented foods increase your diverse fiber. So eat in abundance of all of these different fruits and vegetables, things that you might have no idea. When you're walking into Kroger or Walmart or wherever you shop and you see a vegetable that you're like, what in the heck is that? I don't know. Bring it home. Try it. See what you can do with it. Go out to your expansion of things that are beyond your peppers and your carrots. It's crazy when they break down the statistics on how many people don't eat a diverse species of what they should be eating. So increase the fiber, remove ultra processed food, remove the processed carbs.
Pastas, breads, bagels, muffins, pastries, all that.
And it's not processed, or it's not carbs that we care about. Bananas, broccoli, sweet potatoes, those are all carbs. That's fine. I want you to stay away from the nutrient-dense
carbs
or nutrient-depleted carbs.
And remove sugar. We already said that, yes.
Yep.
Remember, butyrate, keep that in mind, the tight junction integrity in your gut, lowering those inflammatory cytokines, leading to healthier neurotransmission, starts in the gut. Finally, number 3, increase vagal tone. Get sleep. Do practiced indirect things such as nasal breathing, in through the nose, out through the mouth. They call it, the stage 4 breathing, where it's like in 1, 2, 3, 4, hold 1, 2, 3, 4, out 1, 2, 3, 4, that kind of stuff. That all increases vagal tone. Meditation, singing and humming increase vagal tone. I know that sounds silly, but doing little things, if you're in your car, hum a song, sing a song, like that stuff helps.
Yeah.
Cold exposure, we talk about that maybe not necessarily every day, but a couple times a week.
For the people who have adrenal issues, thyroid issues, limit cold exposure.
And then heart rate variability training, that will show up in different things like exercise, weight resistance exercise, things like that. Stronger vagal tone is more anti-inflammatory signaling. And finally, another way to repair this brain gut axis, we mentioned first, stabilizing blood sugar, second, healing the gut, third, increasing vagal tone, and 4, reduce that toxic load.
Yeah, filter your water. I think we have an entire podcast on water. Maybe we do, or maybe it's in the toxins.
We haven't done it yet.
Filter your water, guys. It's disgusting what they allow into the city water and well water, so please just do yourself and your body a favor. Do not drink microplastic water bottles. Throw them out the door, window, wherever you
Episode 17 is lower your toxic load.
Yeah,
we haven't done a full water
improve
episode.
Improve your filtered water, improve your filtered air. Your house is your lungs. So we spend majority of the time indoors. Random fact for you, inmates in prison actually get more outdoor time than we do, which is insane. But what you're living in every day, your office, your house, please make sure you have some type of air purifier. If not, that's going to be your lungs. And my air doctor gets raging every single day if we're cooking something it doesn't like. If we have the windows open and the farmers next door spraying glyphosate, it gets really pissed off. We have to close the windows. So just remember, do what you can to support your body. Avoid fragrances and toxic products in general. If it smells super foofy, it probably is. I'm okay with essential oils. Everything else, probably no. Be careful of what you're putting on your body, your deodorants, your soaps, all the things. And choose organically when you can. Dirty Dozen, Clean 15, those are some good things for food. If you feel like you have to be on a budget, that's the way to go. And then, minimize your exposure to chemicals every single day. Your brain and your gut will thank you.
Reducing that toxic load will lower oxidative stress. It will increase and make better mitochondrial energy, leading to clearer cognition. So that whole brain gut axis.
And we're talking about those toxins. Go back to endocrine disruptors. We'll tell you why those toxins are so damaging to your body.
Yep, that's episode 30. Check it out. So quick recap. Remember, blood sugar swings can show up as anxiety. Inflammation can show up as depression. Dysbiosis can show up as cravings. Dopamine dysregulation can show up as snacking, cravings, and weight gain. So this is your body's way of communicating with you. Learn to listen to your body. It's not always a weakness. It's not always a disease. Sometimes it's just wiring. It's your body responding in the way it is intended to, which is just not what we want, because we're living this, toxic lifestyle, this ultra processed lifestyle, this 2026 American way of life instead of the 1700s, way of life. So
yep.
Anyway, you can fix this.
Yeah, you sure can. Do what you can to lower your toxic load and support your gut. If you're not sure where to start, you can always book an appointment with us at rixahealth.com. Eat clean, go back to the basics, and usually things will get taken care of themselves there. So if you feel like this resonated with you, you can share this episode with someone who might think that they have anxiety or might think that they have gut issues or whatever the case may be, and try to follow that root cause for what might be going on. Remember, if you're having a symptom, there's always a root cause of why that might be happening. Take control of your biology instead of just trying to outsource it with a drug, meaning if you have IBS, don't be taking Bentyl every meal because your PCP told you have IBS. Well, no crap,
Let's
Sherlock.
get to the root
Let's
cause.
find out why we have IBS. So
Mia,
anyway.
go ahead and take us out. Thank you all for listening, and we will have another great episode for you next week. Please tell a friend. Please like and share.
All right, this podcast is for educational and conversation, not medical advice. It is not the replacement for personalized care, diagnosis, and or treatment. Always talk with your own healthcare provider before making changes to your health, medication, and or lifestyle. Our goal is to give you better questions, better understanding of disease. So like and share and follow. Knowledge is power. We will see you guys next week.